the trinomial was already factorized. So x minus 2 times 3x plus 4 equal to 0. It was already factorized. So you don't have to stress yourself here. Just equate each factor to 0. So this will be x minus 2 equal to 0, or 3x plus 4 equal to 0. So this will give you x equal to 2, and that one will get x equal to minus 4 over 3. There is no need here to remove brackets, please. As long as you've got two binomial factors and there's an equal sign on the right hand side, there is no need to remove brackets. No need. Okay, so that's straightforward. It is 2 marks, so 1 mark for each answer. Then we are done. Then 1.1.2 now, that's a quadratic inequality. Because if you multiply the first binomial by the second one, obviously you get a quadratic inequality. But the quadratic inequality, each trinomial was already factorized. Okay, so we have our two critical values there. Okay, so this will be 1.1.2. Our critical values, the solutions to 1.1.1 are our critical values for 1.1.2. So our critical values will be x equal to 2 and x equal to minus 4 over 3. Then we need to use the graphical method or the number line method. Any of the two. It's your choice. Okay? Now, the good thing about the inequality is that it's given as x minus 2 times 3x plus 4 is less than 0. So if I remove brackets, I'll get my quadratic polynomial, okay, which is less than 0. Therefore, if I draw my number line, I'm going to have minus 4 over 3 here, and I'm going to have a 2 here. If I draw my sketch, it will look like this. Okay? Now, because the trinomial that you get here is less than 0, it means we are talking about the region from here all the way up to there. Okay? It's less than 0, so we are talking about below the what? The x-axis. I hope you understand when I say below what I'm talking about. Below the x-axis, y is what? Negative. Okay? So the solution there is going to be x lies between minus 4 over 3 and positive 2. That's your answer. If you don't want the graphical method, then use the number line. There is also a third method. It's a table method. Okay, but I didn't teach you based on the table method. I only discussed the graphical method and the number line method. So you have got two methods. There is no way that you can tell me you can't solve an inequality because Mr. Chiponda taught you two methods. Surely you must understand one of the two. Okay? So if you did the question, you are supposed to get this as your answer. It's 2 marks, so the mark will be allocated for the answer. Okay? The mark maybe you can have a scenario where 1 mark for the answer, another mark for the method. You must show the method that you used. If it's the number line method, you must show it. If it's the graphical method, you must show it. Because sometimes they can split the marks into the method and then the final answer. Are you following that? So any of the two. Nobody should get scared because you saw a quadratic inequality. Nobody should get scared. Alright? Let's get on. Is there anybody who has got a question here? Any question? Right? Now, you need to know that this topic here is very important until metric. Every metric paper 1, first question, they will test you on these concepts. If you don't understand them now in grade 11, next year you'll be at high risk of getting poor marks. Because the first question we have this. Right? For a June exam, we are going to put the term one word, these quadratic equations, quadratic inequalities. Alright? Then 1.1.3. Now before I do 1.1.3, allow me to just duplicate this page. Okay, I've duplicated it. Right? Now, the equation says 5x squared minus 11x plus 4 equal to 0. That's a quadratic equation in standard form. But there is an instruction here. Your answer must be to 2 decimal places. What this means is you can't solve this by factorization. It's not possible. You won't get the factors. So don't try to waste time trying to factorize that trinomial. You won't be able to factorize. So what you do, use the quadratic formula. Okay? Use the quadratic formula. So this is 5x squared minus 11x plus 4 equal to 0. Don't waste time trying to factorize the trinomial. It's not possible. Okay? And the best method at this stage of solving a quadratic equation is by using the quadratic formula. That's the best method so far. Right? Because some of you have got issue with factorization, then use the quadratic formula. And with the quadratic formula, you never go wrong. You always get your correct answers. So x will be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So I've written my quadratic formula first. You must write it down because sometimes you never know a mark can be allocated, but generally they allocate for substitution into the quadratic formula. Correct substitution. So our b is minus 11. So the minus 11 plus or minus the square root of b squared, that would be minus 11 squared minus 4 times a, our a is 5, times c, which is a 4. This is all over 2 times 5. So you get a mark for correct substitution into the formula. Okay? By correct substitution means you are just replacing the b by a specific value there, the a by a specific value, c by a specific value, the a by a specific value. Don't try to simplify and have plus 11 The correct substitution, this is how it's done. Then let's simplify. So we get positive 11 plus or minus the square root of 121, then minus, that's 20 times 4, that's 80. This is all over 10. Okay? Now, the number inside the square root, that would be 121 minus 80, that will give you 41. 41 is not a perfect square. That's the reason why you get irrational roots here. Because the number inside the square root, which is called the discriminant, is not a perfect square. If it's a perfect square, then you get 2 real roots. But here, you get 41. So, you get x equal to 11 plus or minus the square root of 41 all over 10. Can someone tell me the 2 answers in 2 decimal places? You wrote you answered the questions already. So I expect an answer. What answer you got? 1.74 or 0.46. Is it positive? They are both positive. Alright, so these are your 2 answers. So 1 mark for each answer, then 1 mark for correct substitution. So this step here is very important. That step there is very important. If you don't get that step, you lose the mark. Then that's a mark, and that's also. So that's 3. All right. Yeah, you have to be a guru of solving quadratic equations. You have to be a guru for solving quadratic equations. Right? Then 1.4. 1.1.4. Now, because we have got fractions there, first thing which must come into your head, LCD. But the denominator on the right hand side is not factorized, so we have to factorize that denominator in order to determine the LCD. Okay? So, we have 4 over x plus 3 plus x over x minus 1 is equal to 12x plus 20 all over. Now factorize that, so you get x plus 3 times x minus 1. Okay, so the first step would be factorize the denominator on the right hand side. That's the first step. Because you cannot determine the LCD without factorizing that denominator. Then, I'm sure you can see here that the denominator here is x plus 3, x minus 1. This is a product. And both x plus 3 and x minus 1 are part of the denominator on the right hand side. Okay, so our LCD is going to be x plus 3 times x minus 1. Okay? Then we need to write some restrictions because we don't want the denominator to be equal to 0. Okay? We don't want the denominator to be equal to 0. So if you put x equal to minus 3 here, you get a denominator which is 0, which will make the whole fraction undefined. So we don't want x to be equal to minus 3, and we don't want x to be equal to 1. If we get our values of x as minus 3 and positive 1, then we have to reject those answers. Okay? We have to reject them. So the next thing here, multiply the denominator, the numerator, by x minus 1. I'm sure you can see that the LCD is x plus 3 times x plus 4. So this will be 4 times x minus 1 plus. And that one becomes x times x plus 3. Since the denominator on the right is the same as the LCD, we don't do anything to the numerator. So that will be 12x plus 20. The denominator disappears. Okay? Right? Or you can say you neglect it. So you get 4x minus 4 plus x squared, which this term here is a clue that you need to create a quadratic equation. Okay? Plus 3x, that's equal to 12x plus 20. Then you need to write this whole equation in standard form because there is a mark allocated for the standard form. So you get x squared, 4x plus 3x plus 7x minus 12x, that will give me minus 5x. Then minus 4 minus 20, I'll get minus 24 equal to 0. Already I'm smiling. I know what factors, okay, of minus 24 will give me minus 5. You must see it at a glance, just like that. Right? So this will be 8x minus 8 times x plus 3. That's equal to 0. Okay? And then, now, be aware that this question has got 5 marks. Be aware of it. Right? So already, you should get a mark here. Then another mark should be here for the standard form. Then the factors. If you decide that you don't want to factorize from your standard form, you can use the quadratic formula. Okay? If you don't want to factorize. So you get a mark for substitution into the correct into the correct formula, which is the quadratic formula. So 3 marks so far. Okay? Then the last 2 marks is for x equal to 8 or x equal to minus 3. Now, you see what happens now? We're getting x equal to minus 3 as part of our last 2 answers, but we have a restriction here. This restriction, because this denominator, if I put x equal to minus 3, I'll get a 0. It means I have to reject x equal to minus 3. Therefore, we have one solution. So we reject this one here. Therefore, our only solution is going to be x equals 8. That's our only solution. And you need to indicate that x equal to minus 3 is invalid. Okay, so there's 1 mark here. You may get a mark for rejecting that minus 3. Okay, please be aware that for this question you may have been tempted to think that x equal to minus 3 is a solution. It's not a solution, because it will make the first denominator to be undefined. Are you following? If you've got any questions, feel free to ask. This is very important until metric. If you look at every metric paper, there are questions on the quadratic equation. Next paper 1. These are the type of questions that you will get. So if you understand it now in grade level, next year you find it smooth sailing. You have confidence that indeed you pass your metric because you know your basics. Any question? Okay. You don't have a question, then let's carry on. Right. Simultaneous. It's always there, even in every metric paper. If you go online, if you want to check, you can check. Which means the first part of your metric next year, so it has already been covered. This is what you should expect as well. All right. So a simultaneous equation is very, very easy. I call these marks here free marks. They are free marks. So we have got 3y as x equal to 2. You can call this one equation 1. And then you have got y squared plus x equal to xy plus y. That will be your equation 2. Okay. Now, the next thing, it's always better to make x or y the subject in the linear equation. Okay? In the linear equation. So I'm going to make x the subject, so that becomes x equal to 2 minus 3y. There is a mark for this. Just making x or y the subject, 1 mark. Okay, remember the question is 6 marks. Right? Then we substitute now where there is x there. We put 2 minus 3y. So this equation 2 becomes, so I can say therefore y squared plus 2 minus 3y is equal to y times 2 minus 3y plus y. That's our new equation. So we are substituting, well, if you want, I can call this equation 3. So we are substituting equation 3 into equation 2. Okay? Then you simplify this. Simplifying this is not grade level. So this will be y squared. Okay, let me remove the brackets there on the right hand side. So I'll get 2y minus 3y squared plus y. Again, because this is grade 11, you need to form a standard form of a quadratic equation. So the second mark is here, putting this 2 minus 3y, where there is x, 1 mark. So already 2 marks. So let me take the minus 3y squared to the left, get 4y squared minus 3y. Okay, these 2 will give me 3y. Take it to the left, I'll get minus 6y. Then plus 2, but there's no constant on the right hand side, so you get that. That's my standard form, 1 mark. So 3 so far. Okay? Now, the standard form, fortunately, it can be simplified. Common factor is a 2. So I'll take out 2. Okay? Because I don't want to use the quadratic formula. Okay? But please don't say that Mr. Chiponda likes to factorize or want to factorize. It might end up wasting your time. So use the quadratic formula. So my simplified equation becomes 2y squared minus 3y plus 1 equal to 0. Then this 2 times the 1 will give me a positive 2. Okay, because I like to factorize, so I can break that minus 3y into 2y squared minus 2y minus y plus 1. Then I'll factorize this. So that will be 2y times y minus 1. Then there I'll factor out minus 1 and I'll get that. Okay? I'm factorizing. That which should become natural to everybody. So this becomes y minus 1 times 2y minus 1 equal to 0. So y is going to be 1 and y is going to be positive a half. So if you answer these questions, you should be marking your work, not to see it for the first time. Okay? So, when y is equal to 1, what is x? So we substitute here. 2 minus 3 times 1. So x is going to be 2 minus 3, which gives me x equal to negative 1. Then, when y is equal to a half, so x will be 2 minus 3 times a half. That will give me 3 over 2. So if I subtract there, I'll get x equal to a half. So these are my two sets of solutions, right? There's no need to write them as ordered pairs. There is no mark for that. So just to let you know the mark allocation. To summarize it, okay? So first mark, making x or y the subject. We have to show that. Then substitution into the other equation. Okay? Your standard form, you can give it there or we can give it here. It's two standard form. Then factors. Okay? Where are my factors? My factors are here. Okay? If you use the quadratic formula, then we give you a substitution into the quadratic formula. Then the y values, both of them, if one is incorrect, then you get 0. Right? Then we can give you what's called the CA mark, whereby if you make a mistake, your y value is there. Then you use those y values to get x. If that's correct, mathematically, then you get your mark to the CA. You end up getting 5 out of 6 there. Okay? Also, if you make a mistake making x the subject, and everything after that is correct, you get CA marks, you get 5 out of 6. But if you make a second mistake, no more CA marks. Okay? So you should at least be perfect and get total marks, or you make one silly mistake and get 1 mark down. Then it's better. Okay? Are we following? So you look for questions, you practice, this should become natural. Okay? Any question? Any question? Can you sit straight? I need the body language is very important to me. Body language is important. You can see the way that I'm talking, that I'm interested in what I'm doing. Yes. Yeah. Any question? Up to simultaneous? In this class, I don't expect anybody to get a simultaneous wrong. Solve a quadratic equation wrong. No. No, it's a big no. Okay? If I was allowed to give someone a hiding, I would do it for not solving a quadratic equation correctly, not solving simultaneous equations correctly. Yeah, you must feel guilty inside you. All right, 1.3. 1.3. Now, 1.3 is a question on nature of roots. How do I know? The question says, for which values of k will that equation have non-real roots? Because of this, it's a clue that the question is talking about nature of roots. Then, what do you know about nature of roots? We use the discriminant. Okay? To get non-real roots, the discriminant must be what? It must be less than 0. That also should be natural. That should be natural. You see a question on nature of roots, you should not think, what is this about? If the discriminant is less than 0, you get non-real roots. We also call them complex roots. If you start maths beyond high school, there's a branch of maths called complex numbers where you deal with situations like that. And some of you here, you are going to encounter that. And you remember that, okay, my high school maths teacher told me about this. Yes. Okay, how many of you want to study engineering? Right, engineering, actuarial science? No one in this class wants to study actuarial science. What about pure physics? Not chemistry, pure physics. Okay, astronomy, astrophysics? No one. If you decide to study medicine, then you say goodbye to maths. Okay. Yes. You say goodbye to maths. Okay. All right. So, can we carry on, please? All right. So we've got our equation there. We need to determine k. K is, in actual fact, that k there, it's more like it's a real number. Okay? More like it's a real number. But we just want to know what are the values of k such that that equation will have non-real roots. Okay? So what we do, your a is 1, b is 6, c is negative 2k. Okay, remember that negative 2k is a constant. Don't forget that. The general equation of a quadratic equation is ax squared plus bx plus c equal to 0. So the c is a constant. So that c is equivalent to minus 2k. Then we want our delta. Delta must be less than 0 if we are to get non-real roots. Okay, what is delta? Delta is equal to b squared minus 4ac. This must be less than 0. Okay, then you substitute here, get 6 squared minus 4, a is 1, and c is minus 2k. So you get 36 plus 8k. So this is how easy it is. Alright? Then we take the 36 to the right, so you get 8k equal to, sorry, 8k is less than minus 36. Okay, let me just check it. My b is positive 6, that's fine. My a is 1, that's fine. My c is minus 2k, so that's correct. Then we divide here by 8. So we get k is less than minus 9 over 2. Okay. K is less than minus 9 over 2. Right? This will be your answer. What this means is, if k is less than minus 9 over 2, if you substitute any value of k which is less than minus 9 over 2, that quadratic equation will always have non-real roots. But if k is greater than minus 9 over 2, okay? Remember, minus 9 over 2 is like minus 4.5. So if k is, say, a minus 4, you will get real roots, and so on. Okay? That's what it means. So k is a real number, but the roots of the equation are non-real. Don't confuse the two there. K will be a real number, but the roots or solutions to the quadratic equation are non-real numbers. Okay? Any question so far? Well, I want you to know that this is one of the easiest questions you can get on nature of roots. Okay? They are more complex questions. Some of them I did them in class that you need to also be aware of. Okay? I did some of the questions in class. Okay, let me carry on. Then, further equations. Right? Exponential. Now, the first one It's very, very straightforward, like a grade 8 or 9 equation. So 16 to the power of x is equal to 1. Obviously, there is no need to convert the 16 to a base of 2. It's unnecessary here. You can just convert the 1 to a base of 16. So 1 becomes 16 to the power of 0. Therefore, x will be equal to 0. That's why it's 1 mark there. Okay? Because it's a very simple equation. Right? Then 2.1.2. Okay? Make sure you pay attention carefully because some of you last time when you wrote the test, you were writing your own things here. That's why I said everybody must be here. So this will be the square root of 2x plus 7 is equal to 4 minus x. Okay? Please be aware that the 4 minus x is one number. It's just that we don't know what x is. If we were to know the value of x and subtract that number from 4, we'll get one number on the right. So treat this as one number. Therefore, if I want to remove the square root sign, I have to write this as the square root of 2x plus 7 all squared. Then on the right hand side, it will be 4 minus x all squared. You don't square the 4 on its own and the x on its own. Please, I don't want to see that. I don't want to see. Because I can assure you that by the end of this year, you are going to get a question like this. If you don't see it in the June paper, you will see it in your November paper this year. So I don't want to see people making the mistake which took place last year. That should stop. Okay? So you get 1 mark for squaring both sides, like that. Then this becomes 2x plus 7 equal to, be aware that here you get a trinomial, which we call a perfect square trinomial. So 4 times 4, you get 16, right? Then 4 times x, or you can say 4 times minus x times 2, that will give you minus 8x. Okay? Then minus x squared, you get positive x squared. Okay? You must be aware that, okay, 4 minus x all squared gives me a perfect square trinomial. How do I get the perfect square trinomial? First term is the square of the first term. The last term is the square of the second term. The middle term is 2 times the product of 4 in x, or 4 in minus x actually. Alright? Okay. So hopefully you answered this. Then let's have our standard form now. Quadratic equations are very, very important. Very, very important. Because they've got applications in other topics. So already here, we are going to end up having a quadratic equation because of this x squared. That's why you have to be a good of solving quadratic equations. Okay? So this becomes 0 equal to x squared. If I take that, I'll get minus 10x. 16 minus 7, I'll get positive 9. Already, I can see that I can factorize that. If you can't factorize, use the quadratic formula. Okay? Use the quadratic formula. So this will give me 0 equal to x minus 9, okay, times x minus 1. So you get x equal to 9 or x equal to 1. Since this is an equation involving square roots, you need to do a check of your solutions every time you solve an equation like this. You don't just stop there. Because one of the answers may be invalid or both of them can be invalid. So you need to check. So let's do a picture starting with 9. You don't have to show it. If you want, you can show. So if you put 9 here, 9 times 2 gives us 18. 18 plus 7, 25. The square root of 25 is a 5. 4 minus 9, that will give us minus 5. So we have a problem. Which means x equal to 9 is not really a solution. Okay? Then put 1 put 1 here. 2 times 2 times 1 gives us a 2 plus 7 you get a 9. Square root of 9 is a 3. 4 minus 1 is a 3. Therefore, we reject the x equal to what? To 9. Our answer will be x equal to 9. That's why you have to do a check. Okay. You following? Okay. Let's get on.
If you substitute 9 into the formula, for the left hand side of you be square root of 25 and the other side be negative 5. And then you square root of that will be equal to 4.
No. You see, when you're working with set equations or equations involving square roots, generally we concentrate on the square root of the positive, right? We concentrate on the square root of a number which is positive. Okay? If we have got square root of 25 on the left, right? The square root of 25 is both a minus 5 and a positive 5. But because we are dealing with set equations, we consider the positive. The positive will give us positive 5 on the what? On the left. But if you put the same value of x there, you get minus 5. That will make the two to be unequal. This is the only scenario where you consider the positive square root of a number because you are dealing with set equations. Like any other question? Are you sure? Right. So, my done here. Yeah. Then exponential expressions. Exponential expressions. Exponential expressions. So, you don't have to be scared because we saw that 1 over the cube root of p squared, all this raised to the power of negative 2. You don't have to be scared. Okay, do you remember when I told you that if you've got a fraction as the base and the exponent is negative, you convert the exponent from negative to positive, then you swap the numerator and the what? And the denominator. So this will be the cube root of p squared, all cubed. Okay? All cubed. Like that. Okay? Then remove the square root. To remove the square root, it's not complicated. This will give you p to the power of 2 over 3, all cubed. Then 2 over 3 times 3, that will give you a 2. So the answer here will be p squared. Okay. So whenever you have got a rational base and the exponent outside the bracket is negative, just swap the numerator and denominator, convert the negative exponent to positive. No need to have an increase in heartbeat because we saw this. You must know what to do and where to start. Okay, so that's the first one. All right. Any questions there? Then the second one now. It looks scary the first time you see it, but you just have to go back to the basics. Okay? So we have got a fraction here with exponential terms, both in the numerator and denominator. Then we've got a minus square root of 45 there, and the whole thing is squared. Obviously, you have to simplify what's inside the brackets. So my suggestion here is, because the First term in the bracket has got exponential terms that are being subtracted. Take out a common factor. Okay, so how do you take out the common factor? Well, my suggestion, since in the denominator here we've got an exponent is 2020, right? Here we have got 2023, here we've got 2021. Just break up those exponential terms such that you create a term, an exponential term which has got an exponent which is 5,000 and 2020. So I can write the first one as the square root of 5. This is not the only way, but that's what came into my mind when I first see it, because I'm not using a memory. So this will be 5 to the power of 2. So I've broken up 5 to the power of 2023 into 5 to the power of 2020 times 5 to the power of 3. Okay? I'm using law 1 of exponents, moving from the right hand side towards the left hand side. Okay, just to remind you, x to the power of n times x to the power of n equal to x to the power of n plus n. So I'm moving from the right hand side towards the left hand side. Okay, then minus. I'll do the same for the second term, so this will be 5 to the power of 2020 times 5 to the power of 1. Okay? Now, I'm smiling now because I've created that 5 to the power of 2020. I'm going to take it out later on. So this will be the square root of 5 to the power of 2020. Now, all this is subtracting the square root of 45, and then that answer is squared. Okay? Now, using the multiplication law of cells, this I can write it as the square root of 5 to the power of 2020 times the square root of 5 cubed minus the square root of 5 to the power of 2020 times 5 to the power of 1. Right? Like that. This is all over. That's all over the square root of 5 to the power of 2020 minus square root of 45. Please, at this stage, don't touch the square root of 45. Don't touch it until you deal with the exponential terms. Okay? Don't touch that square root of 45. Right? Okay, any questions so far? I'm sure you can see where I'm trying to get to. Factorize the numerator for the fraction. So I'll take out the common factor. Are you following? Right, let's take out the common factor. So if we take out the common factor, we get the square root of 5 to the power of 2020, open bracket. Now, be very careful here. This square root of 5 to the power of 2020 must be inside the bracket. So let me put the bracket, the big one, like that. Okay? So, we have the square root of 5 cubed. So that would be the square root of 5 cubed minus the square root of 5 to the power of 1. Now close my bracket. This is all over the square root of 5 to the power of 2020. This is minus square root of 45 squared. So let me put the square bracket like that. So these two will come to 1. Okay? I'm simplifying it. So I'll be left with the square root of 125 minus the square root of 5 minus the square root of 45. All this is squared. You see now, we now have an expression which involves sets. Then 25 here, 125 same as 25 times 5. So I can write that as 5 square root of 2, right? But because this 45 here I can write as 9 times 5. I think, let me put the 5 here. So that should be 5 square root of 5 minus square root of 5 minus 3 square root of 1. Are you following that? Yeah, sorry, I put a 2 by mistake there. It's supposed to be a 5. Okay, now it's simplified. Once you get to this point, you should start smiling. So 5 minus 1 minus 3, that will give you what? A 1. You'll get square root of 5, then square it. And your final answer will be 5. Okay? And remember, this question, no calculator. So you're supposed to show all your working out until you get to your answer. All right? Any question? Any question? Okay, if you don't have a question, then let's carry on. Let's move on to geometry now. Geometry. All right. We just finished geometry last week. Okay? And I feel like, can I have your attention? I'm going to give you more questions when we open school. And I'll give you a break the next few days. And I'll give you a break. But when you open school, I'll give you more geometry questions to prepare you for the assignment and the June exam. Okay? Because I don't want a disaster next year. Okay. Now, the basic idea behind geometry is not difficult. It's not difficult. In actual fact, I believe over the years I've realized that it's also an easy topic. You just have to know how to approach the questions. But before you approach the questions, you need to know your theorems and your geometry concepts. Starting with geometry of straight lines, triangle geometry, your quadrilaterals, right? Now your circle theorems. Your circle theorems are in 3 groups. By now we should know that. Your center theorems, theorem 1 does not involve angles. If you see a question on angles, forget about theorem 1. Okay? Your theorems which involve angles that are center theorem, they start with theorem 2, theorem 3, theorem 4. Okay? Angle at center is 2 times angle at the circumference. Angle in a semicircle, that is angle subtended by a diameter. Also, angles in the same segment. Those are your center theorems based on how I taught you. Then you have your cyclic quad theorems. Opposite angles of a cyclic quad are supplementary. Exterior angle of a cyclic quad is equal to an interior opposite angle. Then the tangent theorems. Tan perpendicular to radius. Tangents from a common point. Then the famous tan chord theorem. That's it. Also, you need to know your corollaries based on theorem 4. Equal chords subtend equal angles at the center and at the circumference. Equal chords belonging to the same to circles that are equal in length. They also subtend equal angles. One o'clock. Okay. Right? So know your theorems. When you see a diagram, don't be scared. Ask yourself, do I have a center? Do I have a diameter? Is there a tangent? Are there any cyclic paths? Are there any lines that are parallel? Also your triangles. Sum of angles in a triangle, whenever you see some triangles, you might need that. Exterior angle of a triangle, you might also need that. But don't be scared because you saw a diagram. Okay, so let's answer this. Some of the questions are very, very easy. Very, very easy. So here, you read the story, you can read that. Write down the size of each of the following angles. You don't have to give reasons yet because it's 1 mark and they didn't state that you must give reasons. But you should know why that answer is equal to it. So FEH, this is FEH, that's the angle there. And we are told in this question that FH is a diameter. An angle subtended by diameter at the circumference is equal to 90 degrees. Okay? So this angle here is 90. So just write it 90 degrees. I'll add the reason here, but there's no mark for it. The reason will be angle in a semicircle. Please, it's not angles in a semicircle. No, it's one angle which is subtended by the diameter. So we say angle in a semicircle. Okay? Right? So here you just get 1 mark for that 90 degrees. Then, in most cases, whenever you get a question with a diameter, in most cases, it's theorem 3. You have to apply it. Then, GFH. We have DFH. Right? Now, we are told that we have got a tangent there. DJ is a tangent. Whenever you see a tangent, the first theorem which must come into your head is the tan chord theorem. You mustn't be scared because you saw a tangent on a circle. In most cases, tan chord. Okay? If it's not tan chord, if there are two tangents that are drawn outside the circle, then tans from a common point. If there's a diameter and there's a tangent, it means theorem 7, tan perpendicular to radius or tan perpendicular to diameter. Right? So here, we have got DFH is equal to 90 degrees. The reason is tan perpendicular to radius or tan perpendicular to diameter. Yes.
So I think that comes from
So tan perpendicular to, alright. Well, it's your choice to write tan perpendicular to radius or tan perpendicular to diameter. But for me, let me write tan perpendicular to diameter. Okay? But be aware that if you put radius, it's too correct. Okay? Alright? Then calculate the size of G. This is G. Okay? Already you must see a butterfly there. Okay? There is a chord which subtends G and F2. They are subtended by the same chord. And that chord is going to be HE. So they are angles in the same segment. So vertex G, vertex H, E, and F, they are all on the circumference, and there's a butterfly there. Therefore, angle G is equal to F2. Your reason is angles in the same segment. Theorem 4. Theorem 4. Okay, but I want to calculate F2 first. Okay, so F1 plus F2 is equal to 90 degrees. And already the reason for this is tan perpendicular to radius or tan perpendicular to diameter. Okay? And F1 is given there. F1, okay, don't need to write F1, I'll just write F2 straight away. F2 is equal to 90 degrees minus 58 degrees. And that will give you 32 degrees. Therefore, angle G is equal to F2. And they are both equal to 32 degrees. Your reason is angles because there are two angles in the same segment. Angles in the same segment. Like that. And then you are done. Sorry? If you know your geometry, you can get an A+++. Okay? Yes. Now we started trigonometry grade 11. The two topics are very important. Okay? Right. Let's move on to the next question. Let me put the diagram to the next question here. All right. Yes. All right. Okay, I'm sorry that this diagram is not very clear, but you should have your paper with you. Okay, you should have your paper with you. Yes. Did we mark it? Yeah, that's why I have to talk about it. Okay, so I gave you this question, you should have done it. Okay, now you are given AD is equal to CD. So these two lines are equal, they are equal, and then you are also given that OD is equal to 14 centimeters, so that's 14 centimeters. Okay, now allow me to just add to make DE equal to X, so that I can end up having a triangle there. Okay, if I join E to C, I can end up having a right angle triangle. But before I do anything, I want to calculate DE, remember. So DE is going to be my X there. Okay? So first thing, we are also told that AD is equal to CD, equal to 48. So it means AD is 48 and CD is 48. Okay? That's the information we have here. Right? Furthermore, now if you look at it here, OE is a radius, OA is a radius, OB is a radius. So it will be much better, based on this question here, to calculate the length of the radius. In actual fact, that's the easiest way. So I'll just say in triangle AOD, in triangle AOD, I can use the theorem of Pythagoras, but before I do anything, I need to state that angle D1 is 90 degrees. Okay, I need to, because it's not indicated there. That is 90. So I cannot just rush to assume that the triangle is a right angle. I need to tell whoever will be matching the answer that I know that D1 is 90. Okay, so D1 is equal to 90 degrees. Now, the reason here is not the original theorem one, it's the converse. So that will be line from center to midpoint of chord. To midpoint of chord. That's the reason why it's equal to 90 degrees. Yes? What? Code what? Well, okay. I realized that I might, actually it's much better to calculate the length of the radius first, right? Because that chord EC, I don't know its length and I don't know X. So to calculate it, it's gonna be a challenge. So I changed my strategy. Okay, so I'm no longer gonna need EC. Okay, I'm no longer needing it. So A or D, I need to calculate the radius. So after writing D1 equal to 90 degrees, it means what I'm saying is that triangle A or D is a right angle triangle by writing that D1 is 90. So I can say AO squared is equal to OD squared plus AD squared. Okay, and my reason is obviously Pythagoras. Okay, so AO squared will be equal to OD is 14 plus AD that's 48 squared. Can someone simplify and tell me what is the length of AO? AO will be what? Huh? 50. Huh? 50. So that will be 50 centimeters. Okay? So I now know that. Well, now it's easy to calculate that x. Okay? Because my radius, now this is also important. You need to also state that AO is equal to OE. Okay? What am I trying to calculate? Remember, it's DE. So I need to calculate the length of what? Of OE. The reason here it will be radar. Okay? So what this means is that OE is going to be 50 centimeters. But OE is equal to OD plus DE. So OE is equal to OD plus DE. Okay? So I can get my DE by subtracting 50. From 50, you can subtract that 40. I'll get 36 centimeters. Okay, well, that code EC is not going to be helpful. Okay, but there are some questions where it might be helpful. The reason why I had to abandon that is because I don't know its length. So I decided to use a different strategy there. Yes? Okay, there are some questions on Theorem 1 where the construction of a chord can help you to solve the problem. But for this question, the construction of chord EC won't help for this question. Okay? Any question? Yes? Hmm. Okay. Whenever you're answering geometry questions, there are times when you might see something that the teachers did not see. It's possible. Okay? And if you use the correct geometry concepts, as long as they are correct geometry concepts, then you deserve full marks. Okay? All right. Any question? Any question? Are you following here? All right. Sorry, girls. Can you be part of the lesson? And, and your body languages are very important to me. Yeah, you need to sit straight and show that you are interested in what we are doing. Okay. Then 4.3 We are given a center, okay? And the circle passes through points A, B, C, and AB is parallel to OB, and we are given an angle here. This is 66 degrees, right? We are supposed to calculate the size of A, that is this angle here, okay? Now, in my case, I don't know how you might have approached the question. I'm just gonna calculate the size of that angle. That is O1. Then I'll use co-interior angles. Okay? So first I'll calculate this using that. Okay, so I'm gonna calculate the angle C. Now to do that, first thing I'll say angle C, angle C plus angle C plus angle B, they give me 180 degrees with their co-interior. Okay? Then I'll state my lines that are parallel, that AC is parallel to OB. Okay? So angle C is going to be 180 degrees minus 66. And that will give me 114 degrees. Okay? Then, please, ACBO is not a cyclic quad because O is not at the circumference. So that quadrilateral there is not a cyclic quad. Okay? So this angle here, it's at the circumference, is going to be half of the reflex. That is O2. Okay? So let me help on that. So my next step is to say angle C is equal to half of O2. Okay? And that will be angle at center is equal to 2 times angle at circumference. Okay? So O2 will be equal to 2 times 114. And that will be 228. Okay? Then, if I add O1 plus O2, I'll get 360. These are angles around point. Okay, please just bear with me here. My e-beam is, is being affected by the wind. So, O1 will be equal to it's going to be equal to 360 minus 228. So that will give me 132. Okay? Then angle A now. If I add A and O1, I should get 180 degrees. So I'll say angle A plus O1, I'll get 180. And these are four interior angles. And again, AC is parallel to OB. Therefore, angle A is going to be 180 minus 132. And you will get 48. Okay, then you are done. So if you did the question, you just mark your work. Okay? If you did the question, just mark your work. Okay, let's move on to question 5. Now, 5.1, okay, 5.1, it's a proof. I'm not going to go over that. You sit down, memorize the proof of theorem 5. This is the proof of theorem 5. Opposite angles of a cyclic quad. Okay, so you memorize that. Remember, to prove theorem 5, you just have to use theorem 2. Okay, use theorem 2 to prove theorem 5. Remember that. So you can work on that. Then 5.2, we have got 20 minutes, so I'll try to finish that. Okay, so in this question, how many of you did this question? Okay, let's talk about it. So the first question says, write down with reasons 3 other angles equal to x. Okay, your x is here, and that's x there. This is x. Now be aware that since Jm is equal to Jt, it means M4 will also be equal to x. So we'll start by writing M4 is equal to x. Our reason would be angles opposite equal sides. Okay? That's where we start. Okay? So M4 is equal to x. Then, if you look at it as well, we have got an angle between a tangent there and a chord. And our chord is Jm. Okay? So Jm subtends angle T, which is x, and it also forms angle BMJ with the chord. Therefore, our second angle is going to be BMJ. This is also equal to x. And the reason will be Hancock theorem. Okay? Do you see that? Huh? Right? Then we have got a cyclic part here, J, K, M, T. And K2 is an exterior angle of that cyclic part. Therefore, it's also equal to x. So we can say K2 is equal to x. The reason will be the exterior angle of cyclic part. Okay, so I have determined 3 angles that are equal to x. Is there another angle? I doubt so. I don't know, but I doubt so. Okay, so these are the 3 that you're supposed to get. Then, let's move on to 5.22. Now, the good thing about geometry questions is that whatever answer you get in the first part, you might need it to do the questions below. So 5.22, we need to determine M it says M3. Okay? M3 is this angle here. That's M3. That angle. Okay? That's our M3. Alright? Now, to determine M3, well, in my case, I'm going to do it a slightly different way. Okay? So I'm going to use triangle KJM. Triangle KJM. Do you see that K2 is an exterior angle of triangle KJM? You see that? So let's move on here. K2 is an exterior angle of triangle KJM. So I want this angle M3 and J2 is Y. So I'm almost done because I know that K2 is what? J. So for 5.2.2, I'll say in triangle KJM, K2 is equal to M3 plus J2. Like that. My reason is exterior angle of the triangle. Okay? What is K2? It's X. I want to calculate M3. Then what is my J2? It's Y. So M3 is going to be X minus Y. Yes? Are you following that? Now I'm smiling because I know that this is equal to X minus Y. Okay? Now, generally, I would suggest that when you're answering, because we give you a diagram, when it's a geometry question, we give you a diagram. So what you do is if you got an answer for an angle, put it on the diagram to make it easier for yourself. Okay? Because some of you would think maybe the answer for 5.22 is not related to 5.21. It's not correct. The geometry questions are related. Geometry questions are related. Okay? They are related. Okay, then 5.23. We now need to prove that Jm is a tangent. Okay? Jm is a tangent. So Jm is a tangent to circle passing through K, L, and M. So we need to prove that a circle which passes through those three, okay, has got Jm as its tangent. So what will be the goal here? Or what will be the goal? What are we supposed to prove for us to conclude that Jm is a tangent? Yeah, if you don't know that, then you'll never be able to do a question like this. Remember, I told that there are two ways of proving that a line is a tangent. If a line is perpendicular to a radius or a diameter, then that line is a tangent. If a line is such that it has got an angle which is equivalent to an angle inside the triangle, like in this case here, the angle we want to prove is M3 must be equal to angle L. Okay, that's the goal. If M3 is equal to angle L, then we can say therefore Jm is a tangent. So you need to know what is the goal. Okay, so we just want to prove that Jm, okay, you write that nicely. So we want to prove that Jm is equivalent to angle L. So all we have to do is calculate the value of angle L. Yes? Okay. Okay? We just have to calculate the value of angle L. And the value must be equal to x minus y. Because M3 is equal to x minus y. Are you following? I hope I'm not talking to myself here. You need to know how to prove that a line is a tangent. There are only two ways. Either a line must be perpendicular to a radius, or a line must be perpendicular to a diameter. Or a line must be such that the angle between it and another line is going to be equal to the angle subtended by that line inside the triangle. Or maybe there's another shape, but it has to be a triangle in most cases. Okay? So you just have to prove that angle L is equal to M3. Then we can go home after that. Okay? Okay? Now, how are you going to do that? Well, someone might ask me, but how is that going to happen? Well, based on the information that we have, okay, we now know that this is x minus y, okay? We know that this is x, that's x. Obviously, this angle here is going to be 180 degrees minus 2x, okay? Based on sum of angles in a triangle, okay? So, I'm going to use that. So, if I add x plus y plus this 180 minus 2x, I'll get this. Do you see that? How many of you did the question? Just be honest. Raise your hand if you did the question. Okay. So, what I'll do is to say in triangle JMT, okay, if I add J1 plus angle M4 plus angle T, I'll get 180. So my reason, sum of angles in a triangle, right? My J1, that's the one I want to calculate. So J1 is going to be 180 minus 2x, because M4 is x, so that will be that. Okay? I'm done now with the first part. I'm not finished. The goal is to prove that L2 is equal to x minus 1. If I manage to prove that angle L is equal to x minus y, then I'm done. Okay? So I'll say in triangle JLT, if I add angle L plus angle T plus angle J, okay, now J is equal to J1 plus J2. So I can just write this J, right? I'll get 180. And my reason is the sum of angles in a triangle. This is so easy, right? So this is angle L plus T, that's x, plus, now J is equal to y plus 180 minus 2x. So this will be y plus 180 degrees minus 2x is equal to 180. Then you solve that. Okay? Let's solve it. So this will be L x minus 2x. That will give us minus x. Right? So we'll end up getting L equal to, if I take the 180 to the other side, it will cancel out with the 180 is already there. So you get 0. Then minus 2x plus x will give us minus x. Okay, but if I take the 2x to the other side, it becomes positive. Subtract this, I'll get x. Take the y to the other side, you get that. Okay? And then from here now we can say therefore M3 is equal to angle L, because that's the goal. Okay? Since those two angles are equal, we can now say therefore, right? Please be careful here now. Therefore, JM is a tangent. Okay, let me write that somewhere here. Therefore, JM is a tangent. Your reason would be converse tan chord theorem. Okay, converse tan chord theorem. Converse tan chord theorem. Then you can smile. Okay.